Okay, guys, we're starting. Listen, we are picking up with question 24 from yesterday. Let's see if I can pull that sheet here. I've started the recording. If I call you down, I'm going to embarrass you in front of the next class and whoever else watches this video. All right? All right, guys, number 25. It is 24. No, it's just I need people to be quiet so I can concentrate on what I'm doing too. All right, guys, this problem is a trig function. It says which function has an amplitude that is twice the size and a period that is 3 times the size of the function y equals 3 cosine of quantity x over 4 minus 1 plus 2, okay? So we're going to write down the original function given, y equals 3 times cosine of x over 4 minus 1 plus 2. And then the recipe we're looking at is an amplitude that is twice the size. And we're looking for a period that is 3 times. I know. I got to copy it first. Okay, then I'll switch over. All right.
Is that a minus 1 or is that a times 1?
That's a minus 1. All right. So, guys, this is what we have to work with. And I'm going to tell you, when you're looking at this, we've already seen the sine and cosine function the other day. If you look up here, you have sine and cosine. We know that they oscillate between 1 and negative 1. And we know to complete one cycle, you go all the way to 2 pi. So typically your period for sine and cosine is a 2 pi. And we'll talk about exactly what that is in a second. But let's redraw that. And we're going to look at f of x equals sine x. Okay, just look at that graph. So this graph starts at 0, goes up, turns, comes back down, goes up, and repeats. Okay? We know that it oscillates between a positive 1 and a negative 1 right here.
Hey, are we supposed to be writing this down?
Yes.
This is for the study guide?
I'll have some more on here for the study guide, which I told my other class I'll put that on the board and you can finish copying that tomorrow. Yeah. But there's a couple more things that I will put on here that I'll add to the board for tomorrow. Okay. But guys, we know the amplitude. That is your amplitude. Okay. This is your midline. That's the one that your function oscillates about. But how high you go above that, how high below that, that's your amplitude also. All right. So again, let's think about this. Where does my amplitude occur in this function? So if I do a generic, we'll say g of x equals a times sine of bx plus c plus d, okay? This a right here is your amplitude, okay? So it is the number that multiplies your sine or your cosine function, okay? We got that?
Yeah.
So if I go back to this over here, I know that my amplitude is what? 3. And if I want an amplitude that's twice the size, I'm going to say my new amplitude, A prime, is 2 times that, which is 6. Now, guys, just that one piece of information, I want you to see what that does. And that's easy, right? You just have to know what it is and where it is on the function. If I go back to my answer choices, which ones have a 6 multiplying the function? 2 of them. C and A. So I can automatically rule out B and D as incorrect. And if I didn't know anything else about this problem other than amplitude, I now have at least a 50-50 shot of getting it right. Okay? I don't have to know anything else. Okay? But I want you to know something else about it. Let's say, as far as the function goes, I'm looking at this right here, and I'm like, I don't know where the amplitude sits on this function. You know? I can tell you that somewhere inside this parentheses is my horizontal shift, because that's an x plus a constant, right? What does this plus d do on the outside? What does that do to your function? It does change it. It transforms the original function sign. It's your vertical shift, okay? So every one of these values, they have meaning, okay? They really do. But again, the only thing left for the period is it's somewhere inside this function, okay? But before I go there and show you how to pull that out, I want to say, let's say you didn't remember this on the test, and let's say all I could do is graph it. But I do have an understanding of what period is, right? What is the period of this function? And I'm going to try and use a different color here. Can I do this? Maybe a red or something. Do you see this value right here? All the way to this value right here? That is one complete cycle. That is your period, which in this case is 2 pi. Okay? So your original function, and I know I need to change the exposure. Does that help? I had it turned up earlier because of the calculator. But that's my period of the sine function. It's 2 pi. So the period is the time it takes to complete one cycle. That's not a period over cycle. Sorry about that. The time it takes to complete one cycle. If you guys take a science course, a physics course, or anything like that, and you talk about wave theory, they are going to tell you that the period is a measure from crest to crest or from trough to trough, okay? So I'm measuring between the high points or I'm measuring between the low points, okay? Now, as far as that goes, guys, it's easier seen if you look at your cosine function, okay? Your cosine function also goes between +1 and -1. You look at pi, you look at 2 pi here. This is pi over 2 and 3 pi over 2, okay? So your cosine function starts up here, comes down, goes to a low point at pi, swings back up, and then over and over, okay? Y'all see that? So if I'm measuring on here between crest and crest, do you see how that's also the period of 2 pi? Because one complete cycle, high point to high point is 2 pi in length. Now, if I continue that on, I could go trough to trough, okay? But that's what we mean by crest to crest, okay? All right. So, guys, if I have a function that is a longer period, is this going to look more wavy or is it going to look more stretched out? Yeah, it's going to be stretched out. So what I want to show you first is that if I didn't know how to pull the period out of the function itself, I can actually graph this and look for a period that is 3 times the size. So I'm going to look for a function that's stretched out, okay, compared to the original, okay? So on your calculators, if you will do second mem 712, that resets it. Y'all see that good? You really can't. That's what I'm saying. The exposure is awful. Can y'all see that better?
Yeah.
Okay. All right, so let's type in the original function here. Now, I need to make sure that if we're graphing sine or cosine, and we're not explicitly told that we're in degrees, that I make sure my calculator is in radian mode. Now, I'm going to tell you, when you get your calculators on your final and they've been reset, they typically reset to radian mode. So if you do any other calculations in degree mode, like for sine of 30 degrees or something, you would have to come in and change your mode, okay? But for these right here doing the graphing, typically we're in radians, okay? So if I go to y equals, I'm going to type 3 times cosine of x divided by 4 minus 1, close parentheses, plus 2, okay? And then I'm going to graph that and see what it looks like. I'm going to do zoom 6, and that's what it looks like, okay? So yeah, that's definitely a longer period than 2 pi. Okay, 2 pi would be 0 to 6.28 or something. Okay. But this is shifted. You know that because the 0 point is off the origin. So there has been a horizontal shift, but the period has been stretched on this also. All right. So guys, let's go back to our graph. We've already ruled out B and D as a valid choice. So really I only need to type in the other two functions, okay? So we're going to type in y equals on the next line under y2, y equals 6 times the sine of x over 12 minus 3, close parentheses, plus 1. All right, you guys got yours typed in? That's 6 times sine of x over 12 minus 3, and then plus 1. Answer choice C. I'm going to go ahead and put this one in there, and then I'm going to show you how to make a distinction between the two. But we're going to go ahead and put in Y3 also. We're going to put 6 times cosine of what? 3x over 4 minus 1, close parentheses, plus 3. Now, guys, do you notice that it's mixed between sine and cosine? I'm not looking for an equivalent function. I'm looking for something that has similar characteristics. Are you listening? That can occur with a sine or a cosine function because they both have periods and they both have amplitudes. So I'm not worried about it being a sine or a cosine. Don't base your answer on that. Now, remember yesterday we said we could bold one of these. If I go to the far left on my calculator, go to the far left here and hit enter. That gives me a bold line. And then if I come down here and hit enter, 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 And I'm going to get that little trace thingy. That will trace out the third function, okay? So we'll be able to make a comparison. So if I hit graph now, let's see what happens. Okay, there's the third function. All right, guys, do you see right here? And if you want to know which function you're on and you didn't use the bold, I can hit trace. And right here, I'm on the original function. Do you see that? Because it says Y1 at the top. Okay? If I go down to the bold function right here, that's Y2. Does that have a longer period or a shorter period? Longer or shorter? Huh? Is more, right? What about the other one? This function right here, the third one, it's going wavy, wavy, wavy. Yeah, it's shorter. It takes less time to go from crest to crest, right? The bold one takes longer than the original function to go crest to crest, okay? Because it's been really stretched out. Now, what were we asked to find? We wanted a period that was 3 times the size. Which one applies, Y2 or Y3? Which one would it be? Y2. Yeah, Y2. And Y2 would be answer choice A, okay? So again, just based on the knowledge of amplitude, we're able to rule out 2 answer choices. And then based on a little more knowledge as far as the definition of period and what it is, that you're completing a cycle or measuring crest to crest, I can graph these against each other and get the correct answer. Okay? Now, is there an easier way than graphing? Yeah, there is, actually. Okay? I'm going to get rid of the calculator right now, and we're going to do a little more algebraic stuff, I guess. So if you look at this, if I gave you a function y equals sine x and y equals sine, we'll say this is a and this is b, sine of 1/2 x, which one of these is going to hit 2 pi the quickest? Like, when does this one hit 2 pi? What value of x? Not 1/2. X over what is equal to 2 pi? Multiply up, I get x equal to 4 pi, right? So compared to the first function, this has twice the period, right? Now, if I said y of c sine of 2x, I'm sorry, that's supposed to be x. When does that hit 2 pi? Well, that hits it at x equal to pi, right? So that's quicker, right? So the period is actually shorter, okay? Y'all see that? So if you notice, it's the number that multiplies x that's controlling the period, okay? So if I go to this function over here, g of x equals a times sine of bx plus c plus d, I'm going to take this and I'm going to factor b times x plus c over b plus d. All right. Guys, that value of b in the function contains your period. Okay. All right. So the period is actually equal to 2 pi over b. Okay. All right, so what's the period of the original function? The original one here, the number multiplying x is 1/4. So the period of the original function is 2 pi over 1/4. And you guys know to divide by a fraction is the same as multiplying by its reciprocal. So you end up with 8 pi. Okay. Now, what kind of period did they want us to have? They said, hey, let's do one that is 3 times the size. Yes. Okay, so P prime. Guys, my new period is going to be 3 times the original, which is 24 pi. Okay? So all I would have to do is go to my original functions, A and C, because we are already ruled out B and D based on amplitude. And I asked myself on answer choice A, guys, on answer choice A, the number multiplying x is 1 over 12. So if I do 2 pi divided by 1 over 12, I get 2 pi times 12, which is 24 pi. Okay? Since 24 pi is exactly the period I'm looking for, then A is the correct answer. Okay? So again, this is a really easy problem if you can divide two numbers. Okay? Or you know your definition of period and you can graph the functions against each other and answer it that way. No. Ethan. I got it right. You're not doing all of this. I'm saying the amplitude is easy, right? That's just identify it and multiply by 2 and compare to the original on the answer choices and rule out B and D. The period, I'm either going to recognize how it's defined and graph the two remaining answer choices against the original function and answer the question, or I'm going to come over here and take the original function and find its period, and then take the answer choices A and C and find their periods and see which one is 3 times the original. Okay? You're not doing both of them. You just need to do one of them to answer the question. And if you can't remember either of those, at least remember amplitude and rule out at least 2 of the choices. Okay? And again, if you remember me telling you the other day, if you can rule out 2 answer choices, use that little tool and X those answer choices out. So if you flag the question to come back to, you at least know you've already ruled out 2 choices. Okay? And if you have to last minute guess, you're at least guessing with the 2 that you know it has to be and not all 4 and then miss the question. Okay? So again, please be smart about that. Use those cross-off tools if you can rule out answer choices. Okay? Because I'm telling you, if you got to come back to it and you've already ruled 2 out and it's the end of the test and you got to answer real quick, you don't want to be guessing from all 4. You just want to guess from the 2 that you know it has to be. Okay? All right. Any other questions on period, amplitude, whatever? All right. So we're going to switch back. Let's back up and we're going to go to question number 25. Okay? All right, 25 right here. Come on, Bubba. About a third of the class missed this one. Okay? Yes, that's what I'm saying. When I see that 30%, that's probably exactly what that is. And I'm not saying it's for everybody, but it's a high likelihood. Okay. Okay, this one, guys, says given the table below, which function fits the data? Okay, before I touch my calculator, before I start just guessing, can we think about what pops into your mind when you see this problem? What type of problem have we done in the past where you've used a table of values? Huh? Nice. Well, yeah, that's expected value. Yeah, you're building the table there typically. But I'm saying you're given a table of X and Y data.
Devin said scatter plot.
Scatter plot. Yeah. That's exactly right. Okay. Guys, that's my first stop on this problem. Okay. We're going to plot this data on a scatter plot. And I think you're going to see you can learn something just from the scatter plot without doing anything else that's going to rule out at least one of the answer choices. Okay. So if you'll take your calculator and we're going to clear that out. And I'm just going to do second mem 712 again. Just reset the whole thing. All right. And lighten that up a little bit for you guys. Can y'all see that? Or did I make it darker? Is that better? Okay, guys, do you see right above? Do y'all see right above this house top key, carrot top key? Do you see pi? Please use pi. Don't use 3.14. Typing these in. Use pi. Okay? Your calculator will take that just the same. What's my keystrokes to put in my data? We're going to go to stat, edit. Okay? Now, if I go back to my table of data, the first one is pi over 2. I can do second carrot top for pi divided by 2. And it will do the calculation and put it in there. It's going to put it in as a decimal, though. The pi over 2 for x. All you have to do is type pi over 2, pi divided by 2, and it's going to put in the decimal version. Okay? So don't do no 3.14 junk. Just use pi. Guys, I'm going to go ahead and type in my x and y values. Can you guys do that on your calculator using the pi to type it in? Okay? So we're going to do 3 pi divided by 4 pi 5 pi over 4 and 3 pi over 2. And then we got 0.5, 0, negative 0.5, 0, 0.5. All right. Y'all let me know when yours is typed in.
We're going to try this.
Yes. Is everyone's data typed in? All right. Guys, once your data is typed in, we're going to graph it. What do I do to graph a scatter plot? Second y equals. You have to make sure your first stat plot is turned on. So hit enter, enter to switch it on. If you've cleared your calculator, it defaults to scatter plot. It defaults to list 1, list 2. Okay? So now, what do I do to look at the graph? Zoom 9, which is zoom stat. All right. Guys, that is your data. Okay? TJ, what does this plot tell you? What piece of information can I gather from this plot regarding a trig function? Were you paying attention a while ago? Not this problem, I'm talking about previous problem. Yeah, so what is that point right there in the middle? Imagine a curve going through all that. Is the what point? The minimum, thank you. So your low point, right? Yeah, that's what I'm saying. And that's what you need to know, because if you know that's your low point right here, y'all see that? What piece of information does your low point tell you? It gives you what piece of information? The amplitude, right? So guys, if I'm looking at this graph and I know that's my amplitude, and I go back to my table of data, do you see the middle point right there, pi and negative 0.5? What amplitude is this in? What's the amplitude? What's the magnitude of that number right there? 0.5. So if my amplitude is 0.5, which of these answer choices is definitely not right? You're right. It is right. It's going to be D. There's no 0.5 sitting in front of that function. That actually has an amplitude of 1. So this is gone just on your knowledge of amplitude. So now you got 3 choices to choose from. Okay. From this point on, can I just graph these? Yeah. All you have to do is take the remaining functions and go to y equals. And for y1, I'm going to do A, y2, B, and y3, C. So we're going to type these in. 0.5 times cosine of 2x minus pi. Again, y'all can type these in. Do you want me to zoom in a little bit so you can type these in? Can y'all see that better? And the horizontal line for minus is not showing up. That's 2x minus pi. Then you got 0.5 times cosine of x minus pi. Shoot. Sorry about that. X minus pi. And then I got what? 0.5 times the cosine of 2x plus pi over 2. All right, guys, with these functions typed in, again, this is A, B, and C in order. Guys, once these are typed in, you just graph it. Only one of them is going to fit it, okay? So you're looking for the one that passes through all the points. And it looks like it's going to be what? Answer choice A, okay? Now, let's say I got all these on here, and I wasn't sure which one is the actual one. Can I hit trace and find out which function actually passed through these points? Yes, you can. If you can find your x, which I seem to have lost. Y'all see x anywhere? Oh, there it is right there. Go down. That's why. All right, do you see right there? The one passing through the points, you can see up top right here. is Y1. That was A. The one here, that's B. And the other one is C. Okay? All right. Is that good to go? Now, can I ask you another question? Now that you see this, if you knew that 0.5 was the amplitude, and that's a trough, then you know that the other two locations of 0.5 up top, at positive 0.5, have to be your crest. What other piece of information could I got off of the original scatter plot? What measures between crest and crest? The period. So for the period, if you had said 3 pi over 2 minus pi over 2, that would give you 2 pi over 2, which is just pi. So if you looked at the original functions, you're asking yourself, out of these three, which one has a period of pi? Well, this one, 2 pi over 1 is 2 pi. Answer choice B is ruled out on period. But this 2 pi over 2 is actually pi. 2 pi over 2 is pi. So it has to be answer choices A or C. But the only way to really make that determination is actually plot it and determine that. Okay? Or if I weren't plotting, what else could I do? Couldn't I substitute an X value and get a Y value out? Yeah, I could substitute pi over 2 or pi and see which one gives me a negative 0.5. Okay? So there's another way I could have worked the problem. So if I didn't know anything about trig functions, as far as amplitude, period, or nothing, I do know how to substitute an X value and get a Y value. So I can just use basic knowledge of functions and still get that question correct. Okay? Does that make sense? Does that make sense?
Yes, sir.
All right. Now let's say, guys, that you did that and you plugged in A and D gave you a negative 0.5. Let's say they hit that same point. What would I need to do? I'd have to test a second point, okay? Because we're not going to assume that these three functions can't intersect at a common point, okay? It can happen. But you would test a second point off your table and see which one hits both of those points, okay? All right. All right, let's back up. And that was which one? Number 25. So we're looking for 26. Column 26. All right, guys, 26. Yeah, only a fifth of the classes got that right. I'm trying. There's 29 total. 29 total. I can't run it on this machine. Andrew, I can't run it on this. They've turned off developer mode, and I can't install Linux to run my software. Doesn't matter. They did that countywide.
There's web versions of it.
What if you had already done it?
I don't know. I just know you can't. So, no, I've tried.
You tried that, you power washed it?
Somebody asked about free time.
What?
I asked if we could have some free time.
Yeah, when I'm done with this problem. All right.
What?
Okay, guys, this problem is your classic Ferris wheel problem. No, I can't guarantee that you'll see this problem on your test, but when you have a person on a Ferris wheel and they're rotating, the function that defines the height over time or versus time is your trig function, either sine or cosine. Okay? In this case, you're looking at cosine functions. But I want to read the problem, and then we're going to take, before we even look at the functions, we're going to take each of those quantities they give us, and we're going to ask ourselves, what can I learn about my trig function? What part of the trig function does that feed into? Okay? So a Ferris wheel has a diameter of 80 feet. Riders enter the Ferris wheel at its lowest point, 5 feet above the ground, at time t equals 0 seconds. One complete rotation takes 65 seconds. Okay? So if I'm looking at this, I'm going to take each of these in pieces. A Ferris wheel has a diameter of 80 feet. Okay? What piece of information regarding the trig function does that give us? Or would that feed into? What? It's amplitude. Because again, you're going above the center point, you're going below the center point, and you're oscillating back and forth, okay, as far as your height. So your highest point is here. That's going to be not 80 feet. It's actually half that, right? So your amplitude is 40, okay? Now I want to show you, we're going to talk about the rest of the numbers, but just look at the answer choices real quick. Which one of these has an amplitude of 40? No, B, right? You're looking at you were looking at vertical shift. But that 40 is sitting outside the trig function. Just based on that one fact alone, I can get this answer right. Just looking at amplitude. I don't have to know anything else about this trig function. Just the amplitude gives me the right answer. Okay? But again, we're going to talk about each of the pieces, so I'm not discounting the others. Okay, riders enter the Ferris wheel at its lowest point, 5 feet. What part of your function does that 5 feet play into? Add that to your 40 to get that middle point. So that is your what? Thank you, vertical shift. Exactly. Okay, which is going to be 45. Guys, look down here. Which one has a vertical shift of 45? B, the only one. So just based on either amplitude or vertical shift, I can get this answer right. You see what I'm saying? Well, see, that was our topic we didn't get to, right?
So we were at that question.
No. You still got a 9. But you did know about, transformations of functions. So you could have got this right just based on transformations. Okay. Then over here, guys, at t equals 0 seconds, and then it says one complete rotation takes 65 seconds. What is that? What does that feed into? No, the 65 seconds is the what? The period. Because that takes one complete cycle. Low point to low point, you're going around once, that's 65 seconds. Okay? Guys, which of these do you see that on? That's actually going to be answer choice A, answer choice B. These two definitely not. If I plug in t equals 65, I don't get cosine of 1 or negative 1 there, right? It don't happen. Okay? But this right here has a period of 2 pi. Okay? Or I'm sorry, of 65. And at 65, you get cosine of 2 pi, which is a complete cycle. Okay? Of your cosine function. Okay, guys, let's draw this out on paper And I'm going to show you, like, let's say you were reading and you're like, I don't know how to do that as far as pulling those numbers. Some of you may need to see it visually and draw it out, because I'm one for drawing pictures too. But let's draw the Ferris wheel and see what we can learn from that, okay? You know you have a Ferris wheel right here, and that's not very round, but it's close. And I know it's sitting 5 feet above the ground, right? So right here is 5 feet, okay? And you know that you have a diameter right here, okay? And that's the middle of your Ferris wheel. So if the diameter is 80 feet, you know this is 40 feet and 40 feet. And then you know your point you're oscillating about is going to be that middle point there. And how tall is that? That's going to be 45. And then how tall is this right here from the ground? Yeah, that's going to be 85. Okay. So I want to draw right here, because this is going to be my ground level, right? That's going to be my X. And then this is going to be my Y, okay? And I know this midpoint here, this midline, that's what I'm oscillating about. So I have that point there is 45. And I know I'm 5 feet above the ground right here. And I know this isn't drawn to scale, guys, but that's okay. So that's 5 feet right there. I know that's my starting point. And I know as I start going around this that I'm climbing, going up, 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 up. And how high do I go? 85 feet up. So I'm climbing all the way up to 85 feet. And then I start my trip down the Ferris wheel back to the beginning. And I'm probably going to complete the cycle. But we know right here to here is 65 seconds. And that is your period, because that is trough to trough. Okay. So I know I can get period. And I'm sorry, guys. Good gravy. I forgot to change the exposure. And, I'm sorry, y'all. Messing it up. Let's focus again. Okay. What else do I get from this? We get our amplitude right here. Okay. That's amplitude. So A equals what? 85 minus 45 is 40. Okay. So guys, can I start building my function? And this is my vertical shift right here. Is what? 45 feet. Do you see that? So if I take those things that I know, can I come down here and start building my function? Where does cosine normally start out on the y-axis? Does it start out at a trough or a peak? Look up here. Cosine. Peak. So if I'm starting at a trough, that requires that I reflect my function across the x-axis, right? So that requires a negative sign there. My amplitude is 40. Then I have cosine of something inside. My vertical shift is plus 45. Okay. So guys, just that alone, can I come over here and make a choice as far as my correct function? Yeah, we can. Now, what goes inside? I know I'm plugging in time. And I know for one complete cycle, I want it to equal 2 pi. So when I plug in a 65 for t, I need the quantity here to equal 2 pi, right? So the only way to do that is to plug in t equals 65 and get 2 pi is to actually put 2 pi over 65, okay? That way when I hit 65, I'm doing cosine 2 pi, and that finishes the cycle. Okay? Y'all see that? So there is your complete function. Okay? And that's just taken from drawing out what's happening. Okay? But anyways, like I said, just amplitude would have answered that question, but what happens if they have two or more functions that have a negative 40 sitting out front? Then I have to look at other things to make a distinction. Okay. Anyways, I can tell you if you graph A, are y'all listening? If you graph A, I'm sorry, yeah, A or C, guys, can y'all please listen? Because I'm trying to make these problems accessible for any level of math knowledge. The ones that know what you're doing to the ones that you don't have a clue. Okay? If I knew nothing about trig functions, I don't know anything about transformations, I am just lost. I don't know what to do. I went blank on the test. I don't know how to answer this question. What about common sense? Can you use common sense? Yes. If you graph each of these functions like A, and you only have a vertical shift of 5, and you have an amplitude of 80, guess what you're going to be doing? That Ferris wheel is going to take you underground. Does that make sense? Does it make sense that your Ferris wheel is going to go under the ground? Like below the x-axis? Does it make sense? No. So you can rule out answer choice A. Look at answer choice C. I have an amplitude of 40. I'm sorry, a vertical shift of 40, amplitude of 45. It's going to take you under the ground. You're going below the x-axis. Common sense says C is not the right answer. Look at D. You better die and get the cloud, whatever, because you're going to be getting on that thing in the sky. Okay, that's not 5 feet above the ground. When you've shifted that function 80 units up with an amplitude of 5, do you see what I'm saying? You're going to be having to climb the stairway to heaven or something to get on that Ferris wheel. So the only one that's going to make sense is answer choice B. Okay? Do you see what I'm saying? No math knowledge at all. If I can graph that on a calculator, I can tell you some of these make absolutely no sense. I thought so too. When I was first thinking about that, I thought, yeah. And I did not think to tell my last class that. Okay? I just now thought about that, the common sense way of doing that problem. Okay? So, yeah, I'm still coming up with new ways to look at these too. Okay? But that one just popped into my head. And it's hard to teach while you're thinking about that because, yeah, I'm with you, John. A Ferris wheel that goes underground, that would be awesome, especially if you're in a place like the caverns or something and you get to go underground and see a bunch of cavern stuff or something. I mean, that would be pretty fascinating, you know? But anyways, that's that. Or, hey, that's a new ride at SeaWorld. No, it could be a Ferris wheel that takes you underground and you got all these aquariums that you can look into.
The glass breaks and like 90 people drown.
Naysayer.
Probably why that hasn't been built.
That was a good idea, too.
Totally walk through a SeaWorld and you get
You
surrounded.
get stuck and then the glass breaks, like the death toll will be staggering. The sharks are gonna have a nice lunch.
No, guys. How can you take what Andrew just said and solve that problem so the ride would not drown people? What could you do?
Don't get on it.
Huh?
Don't go blood excess.
No. What if you had this, guys? You got this, and down here at the bottom, can y'all see that even? Do you see right here? No, hold on, y'all. Give me a chance. You got your Ferris wheel, right? And you got your little riders here on the Ferris wheel car. And you got all this water over here, and the water's on this side too, you know. But you don't want them to drown. If the glass were to break, could you not put grates down here to drain that water off so it's not going to drown the people or something? Or you can make these things airtight or watertight so water's not going to get into the car. Well, I don't know. I just thought it's a cool idea. It's a cool idea.